Today we're looking at notes S-1, tangent and cotangent values. So you should already have this in your notes from notes O-2. Okay, so you already know the tangent values along the unit circle. You've written them down. Okay, but we're just refreshing today. So tangent values at 0 radians is 0. At pi over 6 radians, or 30 degrees, it's square root of 3 over 3. At pi over 4 radians, or in other words 45 degrees, our tangent value is 1. At pi over 3 radians, or in other words 60 degrees, it's square root of 3. And at 90 degrees, or pi over 2 radians, your tangent value is undefined. Remember that tangent comes from y over x. So that's how these values were found. We've taken the y value at this coordinate and we've put it over the x value, y over x, and that's where these came from. Okay, so another little refresher is what type of tangent values will you have based on the quadrant you're in? So remember, if tangent is y over x, you have to think about in what quadrant, what kind of values do I have? So in the first quadrant, I have both positive and negative x and y values. So a positive over a positive makes a positive. Here in the second quadrant, of course, your x values are negative, but your y values are positive. So if you have a positive over a negative, you're going to have a negative. So that's where these come from. So your tangent values will be positive in the first quadrant, negative in the second, so on and so forth. So on today's notes, or today's assignment as well, you're going to be solving each equation on the interval negative 2 pi to 2 pi, meaning once around the unit circle in each positive and negative direction. Before we start doing that, I want you to get out your pink notes, and we are actually going to copy down the tangent of x parent function and the cotangent of x parent function, because knowing these values we can now come up with our tangent and cotangent graph. So the tangent parent function, f of x equals tangent of x. We can get this graph the same way we talked about getting the sine and cosine graph. So remember, if you take various angles and plug them in, what would your output, what would your trig value be? So let's just look at this real quick. So if you plug in 0 radians, what is your output? Your output is 0. Your tangent value at 0 radians is 0, hence the coordinate on the origin. If you keep going further in this direction, in the positive direction, if you plug in pi over 6, what is your output? Square root of 3 over 3. If you plug in pi over 4, what's your output? 1. If you plug in the angle of pi over 3, what's your output? Square root of 3. And then if you plug in pi over 2, what's your output? Undefined, hence the asymptote. So you notice this curve goes up. That's because these values are increasing. I plugged them in the calculator in case you wanted to see. Square root of 3 over 3 is about a half, close to a half. So that value is about a half. 1 is obviously 1, and then square root of 3 is more than 1.5. Hence, from the origin, we continue to rise upward until we get to that asymptote. And then we could similarly get this portion of the graph by thinking about going backwards, going in the negative direction. Of course, the tangent value here would be negative square root of 3 over 3, negative 1, negative square root of 3, hence the downward curve until we get to at negative pi over 2, until we get to the undefined, so hence the other asymptote. So here on this portion of your pink notes, the domain is all real numbers, except x cannot equal negative pi over 2 plus n pi, n meaning how many periods. Okay, this is just one period. Okay, if I wanted to keep going around the unit circle and around and around and around, of course I'd have more of these curves with the asymptotes on both the left and the right. It would go on forever and forever and forever as long as I keep on going around my unit circle, and same in the negative direction. I would have as many of these as I want to possibly have. So my domain is all real numbers. The formula for finding the asymptotes comes from this right here. based on how many periods you have. So LVA is left vertical asymptote. The negative pi over 2 is the left vertical asymptote. If I say I just want 1 period, then I would plug in 1 here. Negative pi over 2 plus 1 times pi would be pi over 2, which would produce this other asymptote. Our range is going to be all real numbers because, as you can see, this graph goes all the way down, all the way up. Our period is pi, okay, from negative pi over 2 to pi over 2, that's pi. And then our vertical asymptote comes from, we just talked about this formula here, where n is integer values, okay, so whole number values. Our cotangent graph is very, very similar, except it looks as if it's been reflected over the y-axis and then shifted, of course. So our cotangent graph looks like this. Again, these come from your cotangent values. You can think of the same thing, plugging in the angle, getting out the various trig values. Our domain is all real numbers, all x except n pi, so n, the number of periods, right, pi. So that would that formula would give you your asymptotes here on either side. Your range, of course, also is negative infinity, positive infinity. Your period is also pi. Vertical asymptotes comes from x equals n times pi. So hopefully you have those copied down for your 2 new parent functions. Okay, now let's get on to today's assignment. So solve each equation on the interval negative 2 pi to positive 2 pi. We already discussed that. So number 1, and we only have 2 examples, so that's nice. Number 1, tangent of x equals square root of 3 over 3. So think about your unit circle. Okay, think about your unit circle, and we're talking square root of 3 over 3. So where would that be? That's right here. So if that's going to be right here, positive, also another positive trig value would be right here. Remember, this quadrant and this quadrant, quadrant 2 and quadrant 4, would have negative trig values, and we want tangent of x to be equal to positive square root of 3 over 3. So of course here in the first quadrant, and then also here in the third quadrant. So you have to think, since we're on the interval negative 2 pi to 2 pi, you have to think about the unit circle in the positive direction as well as the negative direction. So in the positive direction, what angle is this? In the positive direction, that angle is pi over 6. And this is, remember, pi, so that's 6 pi over 6. So this would be 7 pi over 6. It's just one more than a full pi, one more sixth than a full pi. And then think about if you're still talking about these same slices on the unit circle, but if you're going in the negative direction. So if you're going in the negative direction, this would be negative 5 pi over 6, because you're not quite to negative pi, which would be negative 6 pi over 6. So that's negative 5 pi over 6. And this, if I'm going in the negative direction, is 1/6 pi less than 2 pi. And 2 pi would be 12 pi over 6, but really negative 12 pi over 6 because we're in the negative direction. So this would be negative 11 pi over 6. So those are my 4 angles that would give me tangent of x equal to square root of 3 over 3 if I'm only talking on the interval negative 2 pi to positive 2 pi. Okay, so next example, cotangent of x equals undefined. So remember, cotangent is the reciprocal of tangent. So you would change this to be tangent of x equals, remember, undefined means over 0, right? So if you flip it, that means 0 is on top, so tangent of x equals 0. That's what that means. So here, where on the unit circle do we have a tangent value of 0? So this will be nice. So draw our unit circle. Tangent of x equal to 0 occurs here, and it will also occur here. Okay, so what angles are those? So those are 0, pi, obviously, that's the positive direction. In the negative direction, oh, and also, excuse me, 0, pi, and then we would say all the way to 2 pi, because it does include 2 pi. 2 pi is inclusive. It's in a bracket. So we'd say 0 pi, 2 pi, and then in the negative direction, we're not going to say 0 again because we already have it. Then we'll say negative pi and negative 2 pi. So for this one, we happen to have 5.